When we're trying to determine the domain of a function, we start by assuming that it's going to be all real numbers and then try to find any exclusions from there. So when we're talking about the rational function y equals 1 over x, we know that it's going to be all real numbers except the ones that are going to make the denominator 0. So we can just say that the domain is x cannot equal 0. As the rational function gets a little bit more complicated, 1 over 2x plus 3, remember it's the denominator that cannot equal 0. So just take that the whole denominator, 2x plus 3, and say that it cannot equal 0. And now we simplify. So subtract 3, 2x can't equal negative 3. Divide by 2, x cannot equal negative 3 halves. That means our domain is going to be all real numbers such that x cannot equal negative 3 halves. When we transition over to radical functions, the square root function, we know that what is under the radical, the radicand, x has to be greater than or equal to 0. So when the radical expression gets more complicated, like the square root of 4 minus 3x, we know that 4 minus 3x has to be greater than or equal to 0. And now we just simplify this. Subtract 4, and we got negative 3x. It has to be greater than or equal to negative 4. And divide by negative 3. Remembering your rules about inequalities, when we divide by a negative number, we have to switch the inequality. So x will have to be less than 4/3. That means that our domain is going to be all real numbers such that x is less than or equal to 4/3. And then for the last one, y equals 3x squared minus 4x plus 1. That's just a quadratic, it's a polynomial, and actually right in the description above it said we know that the domain of all polynomials is all real numbers.